Good morning. In this lecture, we're going to talk about this structures and unions in C. So this is a whole new different topic in C programming. Okay, so in C programming, what are the topics that we have covered? We have covered variables, we have covered functions, we have covered data structures, we have also covered file handling. We have covered these are all the basic terminologies or the topics that we have covered from C programming. In this, we're gonna look at structures and union in C. Okay, so this is a different topic in the C programming only. So let's get started. So first is, what is a structure? So a structure is like an array. Okay, so what it does, an array does, it contains the data of same type together, right? Same is the structure, but the only difference is it contains the data of many different types. So what was the drawback with data with array? So the drawback was that you can only store a particular type of data only, right? So that drawback or that disadvantage was solved using structure. So structure is also this is the term that we use to define a structure, are a way to group several related variables into one place. So it's like making a folder. It's like making a resume. So there is a different type of data about you that will exist, like your name, like your address, like your contact number, your marks, and we group them together into a single unit of data, and that is called a structure. So what we are doing here, we are grouping together the similar type of data into a single unit, and that is what we call structure. So each variable in a structure is known as the member of the structure. So what is each variable known as? Each is known as the member of the structure. So this is a general idea about what structure is. It is basically used to store different type of data together. Each variable will be known as a member. Unlike array, structure contains different type of data, like it can contain int, float, string, character all at a same time. So now, how do we create a structure? So this is the basic syntax of creating a structure. We use the keyword struct. This is mandatory. We use the keyword struct to create a structure. This is the name of the structure, and these are all the variables that the structure contains. So struct here is the keyword that we use to create a structure. My structure here, they donates the name of the structure. So this is the name of a structure. Now int my name, this is a variable of integer type that will contain my number. Okay, now this is a variable of character type, my letter, right? So what is happening here? In this data structure, we are declaring two variables that completely have a different data type, but together they form a single unit, and these are known as the member of this structure. When we want to access the structure, we must create a variable of it. So what we do, we create a variable of a structure when we wanted to access it. Use the struct keyword inside the main method followed by the name of the structure and the name of the structure variables. So what we do, we write the struct keyword whenever we want to declare a structure, and then what we do, we write all the definitions or all then we write the name of the structure that we want. So if I wanted to create a structure of my name like Vaishnavi, so I can do that, and all the information it can contain is like it can contain my name, it can contain my address, or you can say my contact number. So it can also contain my contact number, right? My contact number will also be character type. Okay, it can contain you can say what is that, my marks, so int marks. So this is how you define a structure. Okay, so this was a basic constant this was a basic syntax of creating a structure. Moving on, this is what I was giving example. So if we wanted to access this structure, so this is here is a syntax, right? This is a basic syntax for a structure. What happens when we wanted to access it? So we wanted to access it. What we did, this is the name of the this is the keyword, this is the name of the structure, and here we created a object. Here what we did, we created a object. Now with the help of this object, we can access any variable out of that structure. So what we can do, we can access any variable with the help of this object. Similarly as the class works, that is how a structure works. So similarly like class, we can also access any variable in the structure using a keyword, using a object. So access the structure members. Okay, so to access the members of a structure, we use this dot syntax. This is what I told you, that if here I write the name of the structure, these are the variables that are defined inside my structure, and then I go to main, then I create an object of this structure. Then what we do, we can access any variable using this structure. What we can do, we can access any variable using this object of this structure. So here it will print my number and it will print my letter. So whatever information I wanted, I can access that using the object of my structure. Okay, so this is how we access any members. So moving on. Now what about strings in structure? How do we declare? That is also very easy. Like we talked about strings in array, right? We also talked about strings in C. So C does not provide us with a feature of creating a string data type. So we cannot create a string data type, but what we can do, we can use array and character to create string. So I can write here my name, and I can take values like till 10, and this will be my string. This will be a string. So this is how if you wanted to access a string, you can use that same way as we did in the previous slides, how we access the member function. In the same way we can access the strings also. That's not a very this is a easy process. Okay, so this is how you actually do it. You can have a look at the program and you can see how we access the members of a structure. Now, and if you try to access a string like this, there is a possibility that there will be an error. Okay, so you can use this str copy function and assign the value like this. So what you can do, you can also assign the member function structure value declaration in single line, just insert the value of comma separated inside. So you can also access the members or can assign the values at the time of initialization of the object. So this is also one way of doing it. So that is one way of providing providing a simpler version of what we saw in the previous videos. Now copy structure. You can also assign one structure to another. In the following example, the value of S1 are copied to S2. So this was the structure S1 and this is S2. So what we can do, we can also copy the values of one object to another. So that is also possible in structure. If you want to change, modify a value, you can use the dot, and to modify a string, the strt copy function is useful. Okay, so how do we use this is an example. Modifying value are especially useful when you copy data structures. So here was structure 1, and this is what we did. We printed the values, and here we modified the values. So here in the this declaration, we mentioned some values, or we gave some declaration about the values, and what we did, we modified those values later. So what we did, we modified those values later. So this is a real life example. For example, there was a structure or a store called car, and it contained the brand name, the model name, and the year. So I can create different instances of this single structure. I can create different instances of the same structure. So here I created car 1, car 2, and car 3. All the 3 variables had a different name. What did it did? All of these 3 have a different name and different values. So we created 3 instances, we passed these 3 values into it, and then we printed those out. And you can see that 3 objects were created of the same structure, and we accessed them through the members and we displayed those. So that was all it for structure. Structure is a very simple topic. So structure is basically nothing but it is a when we group similar type of data together, that is known as structure. And structure can be accessed with the help of an object, just like a class. We can modify the values of structure if we can, and we can also declare the values at the time of declaration. This is a self-explanatory. This is a very easy topic in the C, and if you just read through the slides, you will get a good idea about what structure is. So there is not much to explain in this topic. So I hope that you got the gist of what structures are. Now we will move to unions. So what are unions in C? Union is a special data type available in C that allows to store different data types in the same memory allocation. So this is basically like a structure, but the difference is you can define union with many members, but only one member can contain a value at a given time. Okay, so the main difference is in here also you can have define many members, right? But only one member can contain a value at any given time. Only one member can contain a value at a given time. Union provide an efficient way of using the same memory allocation for multiple purposes. Suppose if I create an instance of this structure and I don't give them a value for character and I just give them value for integer. So what's gonna happen? This memory is gonna get wasted because this is already initialized, right? So structure when we define is, so this will take 4 bits of data, this will take 1 bit of data, so total it will take 5 bits of data, right? But in union, that will be decided at the time of using or time of initialization, that how much memory it will take. So this in the structure it is predefined, it is already defined the amount of memory that it's gonna take, but that's not the case in the case of union. In this is not predefined, and it is can be changed the type of initialization. So defining a union. To define a union, you must use the union statement. This is also the keyword. Then in the same way as you did while defining a structure, the union statement defines a new data type with more than one member of your program. The format of the union is this. So you have to write union, then union tag, member definition, member definition, member definition. One or more union variables can be defined. So a union tag is optional, and each member definition is a normal variable definition, such as int I or float f or any other valid variable definition. At the end of union definition, before the final semicolon, you can specify one or more union variable, but it is also optional. So you can also specify more variables, but it's also optional. So what this is same definition is same as we look in structure, but the working is totally different. In structure, when we create this, if here it was a structure, what will happen? 4 bits of data will be initialized for this, 4 bits for this, and 1 for this. So already 9 bits of data will be pre-assigned or pre-initialized, but that's not the case in the case of union. So that is the difference between a structure and a union. Now a variable of data type can store an integer, a floating point number, or a string. It means a single variable, that is same memory location, can be used to store multiple types of data. You can use any. So what the question arises, how much actually memory is allocated? So the memory is allocated according to the variable who has the most memory size. So this will take 4, right? This will also take 4, and this will take 1. So what is the highest? 4. So 4 bits of memory will be allocated, and once when we use that, 4 bits will already be allocated. So if you want to use float, that can also be covered in this. If you are using integer, that can also get covered in this, and if you are using character, that will also be covered in this. So this is how union works. So what will happen here? Can store an integer, a floating point number, a string of characters. It means a single variable, that is same memory allocation, can be used to store multiple types of data. You can use any built-in or user-defined data types inside a union based on your requirement. A memory occupied of union will be large enough to hold the largest member of the union. That is what I told you, that it will be enough to hold the largest member of the union. For example, in the above example, data type will occupy 20 bytes of memory space because this is the maximum space that can be occupied by a string. So here if you see, there is float f and character string 20. So this will take 20 bytes, right? And this will take 4 bytes. So what is the highest? It is 20. So what will happen? The data type will occupy 20 bits of memory space because this is the maximum space that can be occupied by a character string. So when the above code is compiled and executed, it produces the following result, that is memory space allocation of the data is 20. If it's the same as structure, okay, so let me explain it side by side. So if I have a structure here, name data, right, and it was containing like int f, float a, and a character character b 20. Okay, these were all the three variables. Now in side by side there is a union data. It contains an int f. Same variables are contained by both of these. Now we will see what is the difference between these two. So now here the total memory allocation will be, if I look into a stack, so what will be the total memory allocation? Here some data will be assigned to f for integer, that is 4 bytes. Then 4 bytes will be assigned to 8, which is float, and 20 bytes will be assigned to b, which is character, right? So total memory will be 4, 4 and 20, which will give you 28. So 28 bytes of memory will be allocated when we will construct this structure. So when we define this structure, when we construct this structure in the memory, 28 bits of data will be already allocated for it, bits of memory space. Now when it comes to the same union, so we already know that this will take 4, this will take 4, and this will take 20. Why 20? Because character takes 1 byte, and when we multiply it with 20, that is the size we have declared, so that will take 20 bits. Okay, so what will happen? This will take 20, this will take 4, and this will take 4. So what will happen here? We will not have separate, but we will have just a 20 bytes of memory allocation, that is for the character, because that is the highest this whole structure can go to, and then inside it only we have integer 4 and float 4. So what will happen? A 20 bit of data will be allocated in the case of union, and it will be shared by integer and float. So whatever the variable is getting used, that will use the memory allocation. So if I am using integer, so out of those 20 memory allocation, that 4 bits can be used by the integer type variable. So this is the difference between a union and a structure. This is the difference. In a structure, we have predefined memory allocation. In union, we do not. Okay, so where were we? Okay, we discussed here. So this is what we were discussing here. Now, how do we access accessing union members? To access any member of a union, we use the member access operator, that is the dot. So this dot is for accessing. You have seen this in class, you have seen this in structure, you have seen in this union. So what does we do? We create an object using a dot, and that can be used to access the members. The member access operator is coded as a period between the union variable name and the union member that we wish to access. You would use the keyword union to define variables of union type. The following example shows how to use union in a program. So this is a union. We defined an integer type variable, a float type variable, and a string type variable. Now what we did in the main program, we created an instance of that union, that is data, and we accessed the first variable using data I, that is we initialized its value to 10, then we initialized the value of float to 20.5, and we initialized the value of this string to C programming, and we displayed this data one by one. So the output will be this. The above code is compiled and executed. It produced this output. Here you can see the value of I and F members of union get corrupted because the final value assigned to the variable was occupied by the memory allocation, and this is the reason that the value of str member is getting printed very well. Now let's look into some example once again, and we see when we use one variable at a time, that is the purpose of having union. So what we did here, we used it like a structure. We tried to access all the variables at the same time, and what we did, we tried to display those variables. So we initialize the value of all the three variables. We initialize the value of integer, we initialize the value of float, and we initialize the value of programming. So what happened in the output, you can see the two values got corrupted and only third one was shown. Why? Because that was the last value that was initialized. So in the starting, what happened? When we tried to initialize these values, this got corrupted. So this is what happens in the case of union, because that memory was created 20. The only 20 bits of memory were created, and that got occupied by the last code. C programming took the 20 bits of information. So what happened? The two got overwritten. These two got overwritten because there was not a space to store these variables. Now we'll see what happens if we just displayed them singly. So what we did here, we accessed the information and we just printed it. So you see, we got the right result, and we initialized the and we printed it. We initialized and we printed. So what is happening here? When we call this variable first, the 20 bits of memory space was free. So what happened? When we called it, that memory was free. So integer used the 4 bits to store a variable value, that is 10. Now it was able to display it because till this line, no overwriting was taking place. The only space was taken by the variable called int. Now what happened when we declared float, this was overwritten and the 4 bits of information was used by float to print 20.5. And then when we declared a string type, then that was also overwritten. So this is what union does. That's why this is a very good example to see the difference between a structure and a union. So this is what happens when you store the same when you try to access all the variables of this union together. You will see that the information in the variables will get corrupted, and only the information in the last variable will get stored. So this is what difference between union and structure. Okay, so this is the graphical representation. So this is union. Okay, and here we have defined all the different types of variables. So this is float, this is character, this is 10 character, this is 30 character, and this is an integer. So what do you think is the highest memory allocation required here? This is obviously character. This is the highest out of all this data. So okay, what is here? This is taking 4 bytes, this is taking 4 bytes, this is taking 1 byte, this is taking 10 byte, and this is taking 30 byte. So what do you think is the highest memory required here? With the obviously 30 bytes. So no value of these operators or variable will extend more than 30 bytes. So what will happen? That memory will be allocated only 30 bytes to store all the information, because that is the largest value in this union. So this is because this is the largest value in this union, only 30 byte of memory will be allocated. So this was what the basic idea behind structure and union. So what is a structure and union? They are both used to store different type of data together. But the difference between structure and union is that structure has a predefined memory, or it has a fixed memory allocation, and it is this memory is allocated at the time of compiling according to what is defined inside a structure. But in union, it is not predefined. It depends on the value of the highest variable. So whatever will be the memory allocation required for the largest variable, that will be that amount of memory will be stored or will be kept in the during the memory allocation. So this was all about union and structure. So today, now we are done with this union and structure. So we have covered all the topics that we have covered in C programming till now are functions, unions, and structures. And we have covered data structure, where we have covered all the topics like array, linked list, graphs and trees, and stacks and queues. So this is all the data structure that we have covered. This is functions. We also have covered. We have covered the introduction to the programming language, all the qualities and features of C. We have also covered, as far as I remember, constructors and destructors. So that is also what we have covered. And all more topics, I seem to forget about all more topics, but we have covered a fair amount of topics in C. So I'll see you next I'll see you in next video with now we will discuss about file handling. We have also discussed about file handling in C. So that is also one of the topics that we covered. So this was a brief about introduction. So these are some practice questions that you can perform or you can practice. So this is here. What is it's saying? What will be the output of this C program? So look here. So we have a main program. There is a structure and we access that structure using S1, and we printed the value of city, and we printed the value of integer. So tell us what will be the output of this. And next is we have another where we have a structure and all these values, and we did this. So this will be a fun activity for you to try, so please do try it. And yeah, I'll see you in the next video. Thank you.